This video is about using the Gaussian elimination to solve the system of equation given below. Now we first define what we call the augmented matrix. So the augmented matrix is the matrix made up of the coefficient. So 2, 1, negative 1 are the coefficient here in this first equation. 2, 1, negative 1, and then the constant term is put on the right. This is a solid line just to separate the coefficient from the constant term. The second equation, it has got 3x, negative 1y, negative y, and 2. So here 3, negative 1, 2, the constant term, and then the third equation, negative 1, 3, 1 here, and then 4. Now the augmented matrix, as you can see, contain all the information that is in the system of equations. So you can solve this system by using the system itself, the equations, or using the rows and columns in the matrix. Now in this video we are going to use the augmented matrix. Now we are going to use the Gaussian elimination, which uses 3 elementary operations on either the equations or the rows of the matrix. So we are going to use the rows. Now number 1, you can interchange 2 rows. So for example, you can take the first row and put it into the third position, and then the third row put it in the first position. The second elementary operation is that we can multiply all terms in a row, all the numbers in a row, by a non-zero constant. A non-zero constant. The third operation is you can add or subtract rows. Now the Gaussian elimination method now is going to be used to reduce this matrix into row echelon form. So the row echelon form is a matrix of this form here. If you take any 2 rows, the first non-zero, this is the first non-zero in this row, it's to the right of the first non-zero in this row. This is one property of the matrix in row echelon form. And if you have a row with all zeros, it must be at the bottom, somewhere here. So what we need to do is this number here, this one here, this one here, in all these 3 positions we need to have zeros. Now let's call this one is row number 1, this is row number 2, and this is row number 3. And then start the first operation we're going to do is to interchange row 1 and row 3. So this is row 3 here, and this is row 1 here, and this is unchanged. Now the new row 1, row 2, row 3 are here now. Now we need to make this 3 0 here, and we need to have 0 here. How we do this? We are going to multiply by constant and then add rows. Okay, let's examine this coefficient 3. So if we want to eliminate 3, we need the minus 3 to add it to the 3. So what we are going to do, add this row here, row 2, to 3 times row 1. Why 3? Because when we multiply by 3 here, we will have negative 3 here. So negative 3 plus 3, that gives me 0. So let's start with row 1. Row 1 is unchanged, so it will be negative 1, 3, 1, and 4. Now row 2 plus 3, row 1, so row 2, 3 plus 3 times negative 1, that's going to give me 0. and then negative 1 plus 3 times 3, that gives me an 8 here. Now row 2 again, 2 plus 3 times 1, 4, that gives me a 5 here. And then row 2, negative 11 plus 3 times 4, that gives me 1 here. Now let's go to row 3 plus 2, row 1 here. So row 3 is this, plus twice this row. 2 plus twice negative 1, that's going to give me a 0. 1 plus twice 3, that gives me a 7. Negative 1 plus 2 times 1, that gives me a 1. 3 plus twice 4, that gives me 11. So now we have 0 here, we have 0 here. All what we need is a 0 here. There are many ways to do this. I'm going to try to do it in the simplest way so that you understand it. So I'm going to multiply this row by 7 and this row by 8 and then subtract them. Okay. So let's continue. Row number 1 unchanged. I'm going to go, so again, the notation, this is the new row number 1, the new row number 2, the new row number 3, and here row number 1 unchanged. Now we need 7 times R2. This is R2, okay? We multiplied by 7. That gives me 7 times 0 here, 7 times 8, 56, 7 times 5, 35, 7 times 1, 7. So all these multiply by 7. Now this here, I'm going to multiply them by 8. 0 times 8, 7 times 8, 56, and then 7 times 1, that gives me 7. So 7 here, and then 11 by 8, hang on, 8 times 1, it's 8, and here 11 by 8, that gives me 88. Now we have 56 here and 56 here. So to have 0, what we are going to do is to have R3 negative R2. So here it's R3 minus R2. Now the solid line and then the rest here. So R1 again unchanged. So this is R1, R2, R3. So R1 unchanged. R2 again unchanged. Now let's do R3, this minus this. So 0 minus 0, 0. 56 minus 56, that gives me a 0 here. 8 minus 35, that gives me minus 27. And then 88 minus 7, that gives me 81. So now we have the 0 here, the 0 here, the 0 here, and this is called a matrix in row echelon form. And this is easy to solve because if we go and rewrite this, so let's rewrite this again as a system of equation. What we do, we have minus 1, 3, 1 here, and then 0, 56, 35, and then 0, 0, negative 27, and then we multiply by the vector x, y, z, and that's going to give me the constant term, which is this 4, 7, and 81 here. Now let's examine the new system, the system that we have. Now remember, the operations we did allows us to obtain a new system of equation that is equivalent to the original one. They have got the same solution. This is very important to remember. Now when we look at the equation, so if we multiply this row by this column, that will have 0 times x, 0 times y, and negative 27 times z. So when you multiply this row by this column, you get 81. So when we look at this equation, this is an equation with one unknown, only the z. So x and y have been eliminated. That's why we call it the method of elimination. Now it's very easy. You divide both sides of this equation by negative 27. That will give you z equal negative 3. So that gives you z. Now, if you look at the second equation, if you multiply this row by this column, now 0 times x gone, that gives you 0. So that will give you 56y plus 35z. Multiply this row by this column, it gives you a 7. Now this equation has got two unknown, y and z, but z we know already. So we just substitute 56y plus 35 times negative 3. That gives me 7. When you simplify all this, that gives you 56y equal 112. And then if you divide both sides of the equation by 56, that will give you y equal to 2. So we have z and y. What we are going to do is to go to the first equation. So when we write the first equation, it has got all three variables, but two of them are known already. So the first row minus x plus 3y plus z equal to 4. We substitute. So we substitute y by its value because we know already the y equal to 2, z by its value, and all this is equal to 4. And when you solve, you get x equal to negative 1. So we have our solution written in ordered form, x, y, z. The solution is equal negative 1, y equal to 2, and z equal to 3. So few things to retain from here. The three elementary operations do not change your system. Just rewrite it in an easy way to solve. And you rewrite it in row echelon form. You have eliminated two unknown from one equation that gives you one equation with z only, and then you back substitute. The method we have been using, it's called back substitution. You start with z, and then you go up to the second equation, and then the last equation.